Significant figures. Introduction. Have you ever wondered why some numbers are written as 7.20 and not just 7.2? That's because of significant figures. Let's break it down in simple steps. What are significant figures? Significant figures are the meaningful digits in a number that help represents 1. The measured value, 2. The precision of the measuring instrument. Why are they important? Let's say 3 students measure a stick. Student A measures the stick's length as 7.20 centimeter. Student B measure it as 7.22 centimeter. Student C measure it as 7.23 centimeter. The first two digits 7 and 2 are measured confidently, so they are reliable. The last digit is uncertain, so all three values have three significant figures. Definition. A significant figure is any digit in a number that gives meaningful information about the precision of a measurement. The number of meaningful digits which contain numbers that are known reliably and first uncertain number. The number of meaningful digits which contain numbers that are known reliably and first uncertain numbers. Significant figures equals all reliable digits plus first uncertain digits. Significant figure equals all reliable digits plus first uncertain digits. Why significant figures matters? In a measurement, the number of significant digits tells us how accurate and precise the measurement is. For example, 7.20 centimeter means the length is measured with vernier caliber and has three significant figures. The third digit 0 is being fixed. It cannot take any other value than 0. In the second measurement, 7.2 centimeter, it is measured with a simple scale, and the third digit can have any value between 0 to 9. So third value is not known. So it has only two significant figures. Even a small difference changes how precise the value is. Even a small difference changes how precise the value is. Examples. Number. Significant figures. 121.23. Good. It has 5 significant figure because all non-zero digits are important, significant. 1.2. Here too the same rule is being applied. All non-zero digits are important, significant, so it has two significant figure. 0.123. The number is less than 1 and the 0 before the decimal point, that is the leading zeros, are not important. So it has only three significant figures. 0.1230. Here it is a decimal number and the trailing 0, the 0 after 3 is important. So it has four significant figure. 0.0123. Here the number is less than 1. This is the decimal number and the 0 after the decimal and before the non-zero digit. The 0 after the decimal and before the non-zero digit is not significant or not significant, so it has three significant figure. The next, 1230. Here, this is not a decimal number, this is a whole number. Good. So, when a number is not having a decimal point and the trailing zeros are not important, so it has only three significant figures. The next one, 1230 point. This is a decimal number. When there is a decimal point, all digits are significant. So this number has four significant figures. Here you have 2 followed by so many zeros, but there is no decimal point. So the trailing zeros are not important. They are not significant. So it has only one significant figure. 1.53 centimeter, it's equal to 0.0153 meter, it's equal to 0.0000153 kilometer. Good. All are having three significant figures, because this number is a decimal number and the number is less than 1, then the leading zeros are not important. The significant figure is 3. Rules made simple. Rule 1. Example. 1, 3, 4, 2. All numbers are non-zero numbers, so all are significant. So it has 4 digits. So 4 is the significant figure. The rule is all non-zero digits are significant. Let's go for rule 2. The example. 2008. The zeros between two non-zero digits are significant, so it has 4 digits. Zeros between non-zero digits are significant. Rule 3. 30700 point. This is a decimal number. When there is a decimal number, then the trailing zeros are important or significant. So it has how many digits? 5 digits. Zeros before decimal after a non-zero number are significant. Rule 4. Now here you have a whole number without a decimal point. So the trailing zeros are not important. So it has only 3 digits. Zeros without decimal at the end are not significant. Rule 5. Here you have a number less than 1 and it is a decimal number, 0.00345. The 0 after decimal and before non-zero digits are not significant, so it has only 3 digits. For a decimal number less than 1, zeros after decimal but before non-zero digits are not significant. For a decimal number less than 1, zeros after decimal but before non-zero digits are not significant. Rule 6. Here you have a decimal number 40.00. So the trailing zeros are important. It has 4 digits. Here you have 1.0020. It's a decimal number more than 1. The trailing zeros are important. So it has 5 digits. For a decimal number greater than 1, zeros after decimal and after a number are significant. Rule 7. 1.53 centimeter. It has 3 digit as significant figure. This is equal to 0.0153 meter. Here there is a change in unit. Good. How many significant figure it has? It's only have 3 because the number is less than 1. The 0 after decimal before non-zero digits are not significant. Similarly, we go with 0.000153 kilometer. It has how many significant figure? 3. It's always 3. Unit changes don't change significant digits. Important notes. Exact number like 2 in 2 pi are considered to have infinite significant figures. Powers of 10 do not affect the count of significant digits. Conclusion. So remember, significant figures are not just about digits. They are about how precise your measurement is.